Okay, hello and welcome to my channel. Today we're gonna continue MIT OCW problem set from 805. Today we're gonna be doing problem 4, set 1. Right, so this is a finite square well problem. Okay, so let's begin and I'll write the crucial thing. Here you're given the finite square well and z naught is equal to a over h bar 2mv not root that. All right. This is for a. Okay, so a asks you for the number of nodes. Okay, so you gotta know that number of nodes basically means the number of half wavelength that you can fit inside your well region. So the number of nodes is actually equal to the number of half wavelength. And well, as I said, the width of your well is going to be equal to the number of half wavelength times it's going to be the number of half wavelengths. So here you get that number of half wave. It's going to be equal to L over lambda over 2. And here lambda can be expressed as 2 pi over k. So if you want to expand that, I don't think you're required to do it, as you only have to put it in this term and say that this is equal to number of nodes. But theoretically, if you want to expand that, you can calculate your p and your k pretty easily. As yeah, I should probably do that too. And okay, say the requirement here is to put your number of nodes in the dimensionless number in unitary numbers or dimensionless number, whatever. You would have to calculate now the momentum inside the well, which is 2m, your energy, which is E minus V naught, and root this is equal to 2mv naught. Okay, so we have this. We can calculate k now. P is equal to h bar k. So get that k in is equal to p over h bar. P is that over h bar. And you get 2mv naught over a root. And the inside looks a lot like our z. And remember, z naught is 2mv naught a square over h bar square. Okay, so we have this. This is h bar. Okay, so from this guy, you get that this is equal to you can turn a h bar. This is equal to z naught a. Right. Got your k, you substitute it back into here. Number of nodes is equal to L over lambda over 2 with lambda is equal to 2 pi over k. Alright, so with this you substitute the k and width here, length you write as 2a, k in over pi. And so this can be shortened into 2z naught over pi. So that would be it if the requirement for this problem is to put the number of nodes in unitary numbers. Okay, but like this is a finite square wave problem, so we would assume that we would have to put everything in unitary numbers. Okay, so let's continue with B. B is, you have to assume that your well is very shallow and narrow. So Z is very small. Z is very small. Okay, so one bound state only. And you have to put E in terms of V naught and Z naught. Right, cool. So one bound state in the finite square well, meaning that one bound state meaning that it has to be the ground state. And it has to be ground state. So this ground state, therefore it has to be even. Right. Okay, and with finite square wave problem, remember the two really useful formula is well, kappa A, or I can put it is psi equal eta tan eta, and psi square plus eta square is equal to Z naught square. These are your two very useful equation. Okay, now you take a Z naught to go to 0. Due to that, psi and eta would also go to 0. Psi and eta would subsequently go to 0. Therefore, your tangent eta is, you can put it in Taylor series, and this will be a very common occurrence, as you're most of the time you're required to estimate it by putting it in series. So this in series is, I'll write it as f at 0 plus f prime 0x. This is the tangent at 0, so 0 is the secant square, so this is 1. Yeah, you can, this is around approximately x. Okay, so from this, you get that your y is gonna be around, okay, no, psi is gonna be around eta square, right? And from the thing below, or just from here, have psi square plus psi is gonna be around Z naught square. Okay, so get that psi is a lot smaller than 1, so you get psi square is negligible. Okay, so therefore psi is around Z naught square. Right, so you've already got here. Now let's try to calculate, try to expand our Z naught square. Okay, so first is Z naught is gonna be, okay, psi here can be expanded. Okay, so this term this is psi is around Z naught square. Right, so you're gonna square it to get rid of the square root, and just isolate your E. Okay. Isolate your E. Get that absolute E is h bar square Z naught to the 4th over 2ma squared. Right, so you got first part of E. Now remember also from up here, Z naught square is also equal to 2m v naught a square h bar squared. Okay, so from here you can isolate v naught. Get that v naught Okay, this. No, wait. I can just put z naught together with v naught. So it would cancel out the 4 to give you a 2 instead. Yeah, that sounds smarter to do. Okay, so put it like this. So you can put it back in your E here, right? So get that your E now is gonna equal to V naught Z naught square Z naught to the 4th. This is equal to V naught A Z naught square. Okay, so that's the absolute value, and this is the energy for bound state, and therefore your energy would be a negative number. So energy is actually equal to minus V naught Z naught square. Okay, so that would be it for today. Goodbye.